All right, sorry about that. My phone ran out of memory, so I had to move some stuff around. But yeah, back where we were. So we need to find this term b because we don't know what it is. They only told us the initial value, and they gave us the ax term as well. So they've also told us that. Oh, I'm seeing a mistake in my work. I really should have used t here since we're talking about t as the independent variable, not x. Right, I'm modeling this off of ax squared plus bx plus c, standard form for a quadratic equation. All right, so they told us that the diver is going to hit the water after 1 second. So seconds is represented by my variable t. So I'm going to plug 1 in anywhere I see a t. So -5 times 1 squared plus b times 1 plus 7.5. Right, now I'm going to simplify and solve for b. And I'll do that right here. We still get 0 equals 1 squared is 1. So 1 times -5 is just -5. B times 1 is just b. And then that'll be 7.5. So to get b alone, I add 5 to both sides first. And I get 5 equals b plus 7.5. Then lastly, I'm going to subtract 7.5 from both sides. And we get -2.5 equals b. So my whole equation is going to be h of t equals -5t squared minus 2.5t, that's the value we just got, plus 7.5. All right, on to the last one. 24.3, a linear function and a quadratic function. Here are graphs of a linear function and a quadratic function. The quadratic function is defined by the expression x minus 4 quantity squared minus 5. Find the coordinates of p, q, and r without using graphing technology. Show your reasoning. All right, well, this is going to be a decent amount of work, but at this point, p shouldn't be too bad, right? P we know right here is our y-intercept. So if I just simplify this part right here, I should get the y-intercept right away. So x minus 4 squared, I'm going to do the box method real quick. X minus 4 times x minus 4, x squared minus 4x minus 4x, -4 times -4 is 16. Put it all together, and we get x squared minus 8x plus 16. Then don't forget that -5 there at the end. All right, simplifying, I get x squared minus 8x plus 16 minus 5 is 11. So my y-intercept is 11. So I know that this point P is going to be located at 0, 11. All right, now I need to find out what the equation of this line is. So this is just going to be like how we did it in 24.1. I'm given 2 points, so I should be able to figure out what the equation of that line is. So I'm going to stack them so I can easily find my change in x and my change in y. 0 to 7, we went up 7. -7 to 0, we went up 7 as well. So my slope is going to be 7 over 7, or just 1. All right, y-intercept. Well, they already gave us the y-intercept there, so I won't have to do too much work for that. So now I know my equation is going to be y equals, my slope is 1, so just x minus 7. All right, so I've got one equation here, and then I know for this other parabola, that's my equation as well. So we need to find out, how am I going to find out q and r, right? Well, we call when any two functions on a graph meet, we call that an intersection. And we know that their x and y coordinates are going to be exactly the same at these 2 points. So what I can do is, using the transitive property, if y is equal to x minus 7, and this y is also equal to x squared minus 8x plus 11, since these are both equal to y, I can set them equal to each other. And I get x minus 7 equals x squared minus 8x plus 11. All right? Now I'm just going to do exactly what we did for 24.1, and I'm going to get everything on one side. So subtract x, add 7, and we're left with 0 equals x squared minus 9x plus 18. All right, so I could try and factor this, but if I think about the factors of 8, actually, you know, this does work. So I know that if I've got minus 9x here, so my middle term is negative, and my last term is positive, that means that when I factor it, we know we're going to have x and x here. But for two numbers to add up to a negative and multiply to a positive, I know those two numbers have to both be negative. So now I'm going to think about factors of 18. Well, the easiest one is 1 and 18. But obviously those two do not add up to 9. All right, well, how about 2 and 9? 2 and 9 also clearly do not add up to 9. All right, well, does 3 go into 18? Yeah, 3 times 6 is 18. 3 and 6 do add up to 9. So that is the easiest way for me to factor it. I'm sorry, the only way for me to factor it. All right, so now using the zero product property or the zero law of multiplication, I know that since these two factors are being multiplied and they equal 0, at least one of them has to be 0 as well. So I can write 0 equals x minus 3 or 0 equals x minus 6, aka 3 equals x or 6 equals x. However, we are not quite done because they want to know the coordinates. We've only found the x coordinates. And again, we're not finding x-intercepts here. So I can't just say, oh, the y coordinate is 0. Clearly, the y coordinates are a little bit different. So what I can do with these two x values is plug them into either equation, right? Either this equation or that equation to get the y values. Now, it's going to be a lot easier to plug them in for this equation right here because this is going to take way more work. Linear equation is much easier. So let me plug in 3 first. Y equals 3 minus 7. Y equals negative 4. So when x is 3, y is negative 4, I would assume that's this point Q right here. So I'm going to call that 3, negative 4. Now x equals 6. Do the same thing. Y equals 6 minus 7. 6 minus 7 is negative 1. Y equals negative 1. That looks like it's that point right there. So R is going to be 6, negative 1. All right. Have I shown my reasoning? I sure showed a lot of work there. All right. Please like and subscribe. As always, throw a donation. They stopped paying all the teachers at RKA, so I would really appreciate, you know, even if it's a couple cents, anything to sort of to help out would be great. I'm sorry, that was a bad joke. That's not funny. People are really, really out there having a rough time. Very, very lucky to be a teacher. All right. Well, if you have any questions, please comment or email me or whatever. All right. All right. Enjoy your day.